Hello everyone, this is DSA Zindabad. Today we are going to solve the 13th question of our SQL DSA sheet, and the question is threesome. Given an integer array nums, return all the triplets nums I, nums j, nums k such that I doesn't equal to j, I doesn't equal to k, and j doesn't equal to k, and nums of I plus nums of j plus nums of k equals 0. Notice that the solution set must not contain duplicate triplets, right? So what is our main goal? We need to find out those triplets whose sum will be equal to 0, right? And this solution set must not contain duplicate triplet. We need to keep this thing in our mind. Now let's look at the example, which is -1, 0, 1, 2, -1, -4, right? So we need to find out three triplets such that their sum will be equal to 0. And these triplets must not contain duplicate element, right? This node should be the duplicate, right? So now from this, we can consider this pair -1 plus 0 plus 1. So this can be the first triplet, right? Which is -1, 0, 1, right? And second triplet can be one of them, like from there we can choose -1, 1, and 2, right? This will be -1, 1, and 2, right? So this will be equal to 0. So there is one more triplet which can be considered as the answer, which is -1 again, then 0, then -1, right? So it will be something like this: -1 plus 0 plus 1, which will be equal to 0. So this will contain -1, 0, and 1. This will be sorry, we need to consider this element, not this element, right? Which will be equal to -1 plus 0 plus 1, right? Ultimately, its sum will be equal to 0. So we have these three triplets. But from these three, there are two duplicate triplets which are -101 and -101. So we need to return only two triplets from the answer because two of them are being the same. So we just need to return two triplets, which is this, and the second one will be this, into a vector or array, into a vector or array, right? I hope the problem statement is clear to all of you guys. Like, basically, we just need to return three triplets whose sum will be equal to 0. And we must keep this thing in our mind, which is the set must not contain duplicate triplets, right? Must not contain the duplicate triplets, right? So now let's jump into the approach and try to figure out how we can approach this problem. So let's talk about the approach. So first of all, let's talk about the brute force approach. Brute force approach, right? Let's say we have this array which is the same: -1, 0, 1, 2, -1, -4, right? So now whenever we have array in question and we just need to think about the brute force or the naive approach, right? What we need to do, we'll just traverse over the array and follow some conditions while traversing. Follow some conditions while traversing, right? So initially, let's say we'll just traverse over the array and we don't need to think about like how many times we need to traverse over the array because we're just uh, building our brute force approach, right? So let's say initially we are at this element, which is -1. Let's say we fix this element, which is -1. Now, what we are trying to do, we'll try to consider the first two elements, -1 plus 0. Now, we'll select first two elements. Now we'll traverse over the array completely for the remaining part of the array to find the third triplet, to find the third number, which will give us the result to be 0, right? Let's say these are I, this is J, and we need to figure out K from the remaining part of the array. And again, we'll do the same thing for these two elements, which are 0 and 1. So our pointer will be pointing to this and j will be pointing to this, and we need to select k from this. So we need to repeat this process so on, and this will require 3 for loop for the same. So ultimately its time complexity would be big of n cube, right? Since we are not using any extra space, so its space complexity will be big of 1, right? So now let's try to optimize this approach. Optimized approach, right? So let's take the same example, which is -1, 0, 1, 2, -1, -4, right? So we need to find out triplets, right? And initially, like this one is the threesome problem, right? That's why we need to find out the triplets. So now, before moving to the optimized approach, just let's talk about two-sum problem. In two-sum problem, what we need to find out? We need to find out two numbers such that their sum will be equal to target, right? So for two-sum, what will be the optimized approach? We just need to sort the array, and after this, we just create two pointers. Two pointers. First one is left one and the right one. The second one is right one. Right being pointing to the right end of the array and left being pointing to the beginning of the array, right? So now, just following some condition, we need to iterate over the array using these two pointers and we'll get a desired result. This is the optimized approach in case of two sum. So we're gonna use the same concept as we did in two sum in our main problem, right? Same concept, right? I'll also provide the link for the two sum problem in the description so that you can have a better understanding of like how the optimized approach works in case of two sum problem. In the video, you can also refer to the diagram, like how we are going to sort the array, how two pointers are the move, how we're going to take two pointers in case of two sum, right? So I'll provide you with the link to the question, right? So now let's talk about how we're going to use the concept of two sum in case for our problem, right? So we'll be using optimize two sum approach in our problem, right? So how we are going to use this in three sum? We have given this array, which is -1, which have -1 and 0, 1, 2, -1, -4, right? So what does two sum approach says? It says, first of all, you need to sort the array, right? Sorting. So after sorting, we'll get -4, -1, -1, 0, 1, and 2, right? So now after sorting this array, what we'll be doing, we'll just consider like in case of three sum, we need to find three numbers. And in case of two sum, we need to find two numbers. So what we'll be doing, we'll just fix the first element, and for rest of the two element, will follow two sum approach. You follow two sum approach, right? So let's do a diagram for the same. So we, after sorting, this is our array. Let's say initially we are at this position, which is let's say we fix the first element, which is -4. Let's say we fix the first element, which is -4. So the remaining part of the array will follow the two sum approach. What does the two sum approach says? It says there is left pointer which is pointing to the left side of the array, and there is right pointer which is pointing to the right side of the array. So what we'll be doing, we'll just try to calculate the sum of all the elements, which is initially -4 plus -1 plus 2. So this is not 0 equal to 0. So this will be equal to -4 -1 -5 plus 2, this will be equal to minus 3, right? Since minus 3 is less than that of the target value. So for this case, what we need to do? So following the two-sum property, for this case, we'll just increment our left pointer to the right side of the array. Then again, we'll try to find out, since this is the same element, so we'll get the same result, which is minus 3 again. So we'll again increment our left pointer. So this will be equal to still minus 2. Now again, increment our pointer. So this will be pointing to 1. So this will be equal to minus 1, still less than. So after traversing over the complete array, we find that there is no element present which will give us the required result, so that the target will be equal to 0, because ultimately we are getting minus 1 as the answer, right? So from the minus 4, we are not getting our answer. Let's move to the second one. So now our pointer will be pointing to minus 1. So now let's take the case of minus 1. And the remaining part of the array would be minus 1, 0, 1, 2. So initially our left pointer will be pointing to the left side of the array and right to the right side of the array, right? So now again we'll try to calculate the sum minus 1 plus 2. So this will be equal to 0. So this is one of the triplet which can be considered, right? So we find out there is one triplet right over there. So whenever there is a collision between left and right pointer, so we'll try to increment our left pointer and will be decrementing our right pointer. So now it will be pointing to minus 1 plus 0 plus 1. So ultimately this result will also be equal to 0. So we find out one more triplet which is minus 1, 0 and minus 1, right? So after this our array will be finished since both left and right cut out each other, like until there is a condition left less than equal to right? So now let's discuss the third one, which is now our pointer will be pointing to minus 1, which is minus 1 will be fixed now. Now remaining part of the array will be 0, 1, 2. Left pointer will be towards the left side of the array and right will be towards the right side of the array, right? So now we'll try to calculate the sum minus 1 plus 0 plus 2. Now this will be equal to 1. So we'll try to decrement our right pointer. So again, we'll try to calculate the sum minus 1 plus 0 minus 1. So this will be equal to 0. So again, we find out one more sum equal to 0, right? So we'll find out minus 1, 0, minus 1, right? So after this, our array will be traversed. So now our pointer will be pointing to 0, right? So now 0 will be fixed in this case. And the remaining part of the array will be 1 and 2, left and right. We'll try to calculate the sum 0 plus 1 plus 2, which will be equal to 3. We'll try to decrement our pointers and they both cut out each other, right? So we'll stop. So as we can see, like we found out 3 triplets which gave us the required result. So our triplet will be something like this: minus 1, minus 1, 2, minus 1, 0, minus 1. The third one is minus 1, 0, minus 1. As we can see in the question, the the triplets can't be same. These both are same. So we need to return our answer to 2 triplets, which are minus 1, minus 1, 2, and minus 1, 0, minus 1. So as we all know, like we can use hash set for the same, which will store unique numbers, right? So after this, like after finding out all the triplets, what we're gonna do, we'll directly put all those triplets into our hash set so that our hash set will return the same answer, which will give us the true triplets, right? I hope this approach is clear to all of you guys. Basically, we just need to use the optimized version of the two-sum approach in the three-sum problem, and we just gonna use hash set for storing the unique numbers, right? And now let's try to code this thing up. So here we are. So initially what we'll be doing, we'll directly sort our vector nums dot begin. nums dot end, right? So after sorting the array, we'll just initialize one set data structure over there. It will be something kind of like vector because we are going to store vector in the set, right? So now we'll just traverse over the array, fixing one element, right, at a time. So we need to keep this thing in our mind, like we traverse over the array until nums dot size -2. Why -2? Because we're gonna need triplets. So at the end, we'll require three triplets. So we'll traverse until the size become nums dot size -2, right? Then I plus plus. Then after this, we'll try to follow the two sum approach. Now our left pointer will be pointing to left I plus 1. Why I plus 1? Because it will be the second element, right? Except for the first element being the fixed element, which we are fixing initially. Now right will be pointing to nums dot size -1, right? Now the same property, like same approach as we did in to some problem, we'll try to calculate the sum nums of I plus nums of left plus nums of right, right? Now we'll check if sum equal 0. If this is the case, then we're gonna insert this thing in our set. So we'll insert nums of I, comma, nums of left and nums of right. So after this, we'll just increment our left pointer and decrement our right pointer. Else if sum is less than 0, then what will I going to do? We'll just increment our left pointer. Else, what we are going to do? We are going to decrement our right pointer. So at the end of this, what we are going to do? We'll just directly return vector. Now this will contain our result from beginning till end. Now just let's try to run this code. So before this, we also need to keep this thing in our mind. Let's say if nums dot empty nums dot empty nums dot size less than 3, then we need to return the empty, right? So there is one typo over there. Instead of like equal to, we'll just directly return while left is less than right. So now let's try to run this code. So it works perfectly fine. Now let's try to submit this code. Yeah, this works fine. Now let's discuss the time and space complexity for the scene. So here we are. Since we are just sorting our array, it will be a big of n log n. So we are just iterating on the loop 2 times. So it will require big of n square. So ultimately our time complexity will be equal to big of n log n plus big of n square. Ultimately this will be equal to big of n square, right? So talking about the space complexity, since there is no there, we require our hash set for inserting elements in the form of vector. So it will require big of n space, right? So I hope this approach is clear to all of you guys. Thank you so much for viewing the video till the end. Please like, share, subscribe, and comment if you have any doubt. Thank you so much.